Hello everyone. So this time we will going to solve logarithmic inequalities. So when we say logarithmic inequality, it is an inequality that involves logarithm. So kapag sinabi nating logarithmic inequality, meron siyang logarithm symbol, then as well as the inequality symbol. So ano yung mga inequality symbols? We have the less than, greater than, less than or equal to, or greater than or equal to. Okay, so these are the properties that you need to remember when you solve logarithmic inequalities. So first, if b or the base is greater than 0 but less than 1, and log of x sub 1 with the base b is greater than log of x sub 2 with the base b, then x sub 1 is less than x sub 2. Or in other words, reverse the inequality symbol when the base is greater than 0 but less than 1. While if the base is greater than 1 and log of x sub 1 with the base b is less than log of x sub 2 with the base b, then x sub 1 is less than x sub 2. Or in other words, you need to retain the inequality symbol when b or when the base is greater than 1. Again, when the base is less than or is greater than 0 but less than 1, then reverse. Okay, so you need to change the inequality symbol. Okay, reverse. But if the base is greater than 1, then retain. Okay, so let's have these examples. Log of x with the base 3 is less than or equal to 5. Okay, so our base is 3 and that is greater than 1. So we will going to retain our inequality symbol. And then the first thing that you should know is to define our x. So our x must be greater than 0. Okay, so always take note that our x must be greater than 0. Okay, now so let us solve these logarithmic inequalities by transforming this into exponential. Okay, so x is less than or equal to, so we just retain the inequality symbol since our base is greater than 1. So x is less than or equal to 3 raised to 5. Okay, so 3 raised to 5. And then x is less than or equal to, so 3 raised to 5 is equal to 243. So we have the x values. X is greater than 0 but less than or equal to 243. So for our solution set, so it will be x is greater than 0 but less than or equal to 243. So interval notation, it will be from 0, okay, open parenthesis 0 up to 243. Okay, close bracket. So we use parenthesis here for 0 because 0 is not included in our solution. Next, number 2, log of x with the base 4 is greater than or equal to 6. So our base is 4 and that is greater than 1. So just retain the inequality symbol all throughout the solution. Again, let us define our x. So x must be greater than 0. Okay? And then solve this by transforming into exponential. Okay? So we have x is greater than or equal to 4 to the 6th power, or 4 raised to 6. So that is 4096. So x is greater than or equal to 4096. Okay, so we have here the condition: x is greater than 0, x is greater than or equal to 4096. So since that they are both greater than, we will just copy this solution, okay, for our solution set. So for our interval notation, it will be from 4096 up to the positive infinity, because x is greater than or equal to 4096. So we put bracket. So meaning 4096 is included. Okay, number 3, log of x plus 8 with the base 6 is less than or equals to 2. So let us define first our x. X plus 8, again, it must be equal or it must be greater than 0. Okay, simplify. So x is greater than negative 8. So our x must be greater than negative 8. So let us solve this into exponential form. Okay, so x plus 8 is less than or equal. So less than or equal because our base is 6, so greater than 1. Okay, so 6 squared. Then x plus 8 is less than or equal to 6 times 6 is 36. So we have x is less than or equal to 36, and then move 8 going to the right, we have negative 8. So we have x is less than or equal to 36 minus 8 is equal to 28. Okay, so we have here x is greater than negative 8 and x is less than or equal to 28. So in this case, we will going to put our x in the middle. So x is greater than negative 8 but less than or equal to 28. And then for our interval notation, it will be from negative 8 up to 28. So open parenthesis for negative 8 because it is not included, and close bracket for 28 because 28 is part of the solution set. So from negative 8 up to 28. Number 5, log of 3x plus 2 with the base 5 is less than log of 2x plus 5 with the base 5. Okay, so our base is greater than 1, so retain. So let us identify or define our x. So 3x plus 2 must be, okay, always take note, the value of x must be always greater than 0. Okay, and then simplify. 3x is greater than negative 2. Divide both sides by 3. So we have x is greater than negative 2/3. The next, 2x plus 5 must be greater than 0. So 2x is greater than negative 5. Divide both sides by 2. We have x is greater than negative 2 or negative 5 over 2. Okay, so we have here the same base. So just copy. 3x plus 2 is less than 2x plus 5. So 3x, and then move 2x to the left side. So we have negative 2x is less than 5, and then 2 will become negative 2. So 3x minus 2x is simply x is greater than 3. Okay, look for the highest or for the higher value of x here. So we have negative 2/3. Okay, so it will be x is greater than negative 2/3 but less than 3. And then for our interval notation, it will be number 6, log of 2x minus 4 with the base 1/2 is less than log of x minus 5 with the base 1/2. So as you can see, our base is less than 1. 1/2 is less than 1. So we will going to reverse the inequality symbol from less than going to greater than. Okay, but let us define first our x. So 2x minus 4 is greater than 0. Okay, simplify. 2x is greater than 4. Divide both sides by 2. So the value of x is greater than 2. Another, x minus 5 is greater than 0. So the value of x is greater than 5. Okay, so since that we have the same base, then 2x minus 4. So kanina, less than, then we will going to reverse that into greater than, since our base is less than 1. So greater than x minus 5. Combine like terms, 2x. So from positive x going to the left, it will become negative x is greater than negative 5. From negative 4 going to the right, it will become positive 4. And then 2x minus x is simply x is greater than negative 1. Okay, so kapag ganito, we have the same inequality symbol, x plus or x greater than 2, x greater than 5, x greater than negative 1. So pareho silang mga greater than. So in this case, we will going to choose yung pinakamataas na value ng x, which is x is greater than 5. Okay, so for our solution set in interval notation, it will be from 5 up to the positive infinity. So 5 is not included in the solution set. And that is all for logarithmic inequalities. So I hope you learned from this video, and I'll see you next time.